Is the Philippines in the northern hemisphere? In which hemisphere can you find the Philippines? That said, the Philippines is above the equator and part of the northern hemisphere. These GPS coordinates also place the Philippines in the eastern hemisphere. Trade winds, so named because if you had a ship full of goods to sell or trade and no way to get it to the place you wanted to sell or trade it other than your sailing vessel, a reliable and predictable wind that always blew in the same places in the same direction. The trade winds are winds that reliably blow east to west just north and south of the equator. The winds help ships travel west, and they can also steer storms such as hurricanes. Common terms associated with revolving tropical storm. Path, the direction in which the storm is moving. Track, the area which the storm center has traversed. Vertex, the furthest westerly point reached by storm center. Angle of indraft, the angle which wind makes with the isobars. Vortex, the central calm of the storm. Dangerous semicircle, the half of the storm which lies to the right of path in the northern hemisphere and left in southern hemisphere. Dangerous quadrant, the leading portion of the dangerous where the wind blows toward the path. Navigable semicircle, the half of the storm which lies to the left of the path in the northern hemisphere and right of the southern hemisphere. Through line, a line through the center of the storm at right angles to the path. It is the driving line between falling and rising pressure.
In this video, we're going to learn about tropical cyclones. The first thing you need to understand is that tropical cyclones originate over oceans in tropical areas and coastal regions. If you all know, this is the tropical region. It is the region of the earth near to the equator and between the Tropic of Cancer in the northern hemisphere and the Tropic of Capricorn in the southern hemisphere. Tropical cyclones are known by different names depending on the region. In the Indian Ocean, they are known by simply cyclones. If you go to the Western Pacific side or near the South China Sea, it is called as typhoons. Likewise, near Western Australia, it is known by willy-willies. All these are different names refer to the same type of storm. You must be knowing this that tropical region receives the most solar radiation per area. And the reason behind that is due to the incoming solar radiation that are direct and vertical at the tropical region. And as you move towards the polar region, the angle of the sun rays are not vertical, they are slanting rays. Vertical rays of sunlight are more effective in producing light and heat than slanting rays. And that's why the tropical region is warm. Now that you have understood the main things about the tropical region, let's understand about wind movement. Wind movement is determined by low pressure and high pressure systems. It is the differences in atmospheric pressure that creates pressure gradient and makes the wind move. And wind always blow from the areas of high pressure to low pressure areas. Now the next question is, what causes low pressure and high pressure? Low pressure occurs when air is warm, either from being over a warm land or ocean surface. That means low pressure occurs at a place which is warm. And how does a place become warm? Because of the incoming heat from the sun. That is why tropical region is a perfect place where low pressure occurs. Similarly, high pressure occurs when air is cool, either from being over a cool land or ocean surface. That is why in the polar region, that is your north and south pole, it is a high pressure zone. And always remember, winds blow from the areas of high pressure to low pressure areas. While all of this happens, there's another important phenomena which comes into the picture. It's called Coriolis force. Due to the rotation of the earth rotates towards the east, and that's why the sun, moon, planets and stars all rise in the east and go towards the west. Anyways, due to the rotation of the earth, there is a force that is generated, and it acts perpendicular to the direction of motion and to the axis of rotation. In simple terms, when the earth is spinning in its axis from west to east, and we also know that earth is a sphere and it is much wider in the middle. As a result, the speed of the surface of the earth at the equator is much faster than the speed at the poles. So if anything has to come straight from the poles towards the equator, it gets deflected to the right in the northern hemisphere and to the left in the southern hemisphere. And this force that we are talking about is called Coriolis force. It causes fluids like water and air to curve as they travel across or above the Earth's surface. Due to Coriolis force, the air in the northern hemisphere gets deflected to the right side. Now you might think, no, that is going towards the left side. But then I said the air is going to curve to the right side in the northern hemisphere. To clear your confusion, you have to actually see it from the direction in which the wind is moving. So what I'm going to do is I'm going to rotate this picture and now put yourself in the path of the wind. Now you will be able to see that the air in the northern hemisphere curves to the right while moving from high pressure to the low pressure area. Similarly, in the southern hemisphere, the air is deflected to the left side while moving from high pressure to low pressure area. In this case, we don't have to rotate the picture. Now that you have understood why the air moves to the left and right due to Coriolis force, just remember this point, that it is because of this reason there are certain pressure belts all over the Earth's surface. You must be familiar with this picture, which shows global wind circulation pattern. You can see that at different latitudes there are different pressure belts. Their existence is simply due to the movement of air to the left and right due to Coriolis force. I hope so far you have understood the general movement of air. Now let's understand how does air turns into a storm and what causes the spinning of a cyclone. When you look at the movement of a cyclone, at the center of every cyclone or hurricane, you will find an area of low pressure, which attracts the cool air. Since we know that air moves from high pressure area to low pressure area, that means the outer area of a cyclone consists of cool air coming from high pressure area, which surrounds the central low pressure area. This region is called the eye of the storm or center of the storm. The low pressure region is a warm region where the air is warm, which expands and then rises. The cool air from high pressure zone rushes in to fill the void left by the rising warm air. This air warms and becomes moist as well, allowing it to rise. Then more cool air rushes in to fill the void. The warm, moist air cools as it rises higher into the atmosphere because temperature drops with increasing altitude. That is also how clouds are formed. Now this process continues again and again. As a result, you will see an eye-like figure at the center of the storm. Now comes the Coriolis effect. In the northern hemisphere, the cool air rushing towards the center of the storm is deflected slightly to the right. But keep in mind, the cool air keeps getting attracted towards the center because that's where the warm low pressure zone is. While moving towards the center, the cool air keeps getting deflected. Now this creates a spin in a counterclockwise direction. In the southern hemisphere, the Coriolis effect moves air to the left, opposite to what happens in the northern hemisphere. As a result, the spinning of the cyclone is in a clockwise direction in the southern hemisphere. Tropical cyclones are intense, and in the beginning we have read that it occurs over the ocean surface and coastal region because there is a continuous supply of moisture from the ocean or sea. When it reaches the land, the moisture supply is cut off and the storm dissipates. When the cyclone crosses the coast, because after that the landmass starts, so the place where tropical cyclone crosses the coast is called the landfall of the cyclone, meaning the power of the cyclone naturally decreases because the supply of moisture is cut off. The average diameter of a circulating tropical cyclone can vary between 150 and 250 kilometers. However, the diameter of the storm over the Bay of Bengal, Arabian Sea, and Indian Ocean is between 600 to 1200 kilometers. And these cyclones move slowly at a speed of about 300 to 500 kilometers per day. So far we have seen the top view of a tropical cyclone, and this is what it looks vertically. This is the eye of the storm. Around the eye is the eye wall. If you look at the height of the cyclone, the circulation of the tropical cyclone extends up to the troposphere. That is around 15,000 to 18,000 meters. When warm moist air rises up in the atmosphere, after a certain height it starts cooling because the temperature drops with increasing altitude. As the air cools, it becomes denser and moves towards the ground. This is called subsiding warm air. And this is what intensifies the storm by increasing the diameter of the storm. And as the diameter increases, the spiral rain bands expands and pushes the rain clouds into the outer region. Tropical cyclones occur at the time of maximum solar radiation during the summer and autumn season, that is around July to October time in the northern hemisphere and December to March time in the southern hemisphere. With this, I hope you have now understood the complete anatomy of a tropical cyclone. If you still find it a little confusing, I recommend
Path, the direction in which the storm is moving. Track, the area which the storm center has traversed. Vertex, the furthest westerly point reached by storm center. Angle of indraft, the angle which wind makes with the isobars. Vortex, the central calm of the storm. Dangerous semicircle, the half of the storm which lies to the right of path in the northern hemisphere and left in southern hemisphere. Dangerous quadrant, the leading portion of the dangerous where the wind blows toward the path. Navigable semicircle, the half of the storm which lies to the left of the path in the northern hemisphere and right of the southern hemisphere. Through line, a line through the center of the storm at right angles to the path. It is the driving line between falling and rising pressure.